Yeah, good evening, friends. Let us continue this differentiation, chain rule, product rule, and trigonometric formulae, whatever we learned in the continuation of this class. So let us start. Go to the whiteboard. I am planning to do now the differentiation of three trigonometric functions, what we left over. Sine, cos, tan, we already learned. Let us see how to differentiate now the secant x. Differentiate secant x. This one we apply the quotient rule, what we learned in the previous class. How we do now? Let y is equal to secant x. Let us say y is equal to secant x. We all know it is reciprocal of cos x. Y is equal to 1 over cos x. Secant x means 1 by cos x. So if you apply differentiating both sides with respect to x, let us say differentiating both sides with respect to x, then dy by dx is equal to d by dx of 1 by cos x. This is numerator part is 1, denominator part is cos x. So u is equal to 1, v is equal to cos x. Now it is in the form of u by v. So what is the u by v differentiation formula? V into differentiation of numerator minus u into differentiation of denominator divided by v square. So this formula I am going to implement here. So first v means cos x into differentiation of 1 minus u means 1 into d by dx of cos x whole thing divided by cos square x. Because it's v square, v is called cos x, so cos square x. Cos x into d by dx of 1 is 0 because it's a constant function minus 1 into d by dx of cos x, that is minus sin x. So our first trigonometric differentiation when we did it, please remember this. Cos square x denominator. So here what you will have, cos x into 0, 0, minus into minus plus. So we will be having only sin x by cos square x. This you can write as sin x by cos x into 1 by cos x. Sin x by cos x is nothing but tan x. 1 by cos x is nothing but secant x. So that means ultimately d by dx of secant x has become tan x secant x. Sometimes we'll also write secant x tan x, both are same. So this is the differentiation of secant x. Please remember this, very simple. Quotient rule we applied. So what is our next one? D by dx of differentiate after secant x, cosecant x. Differentiate cosecant x with respect to x. Same method. Let y is equal to cosecant x. Take the reciprocal, it is reciprocal of sin x. Again apply the quotient rule. What we learned in the previous page checkup. Denominator into differentiation of numerator minus numerator into differentiation of denominator, whole thing divided by denominator square. So this will become sin x into 0 because d by dx of 1 is 0 minus d by dx of sin x, it is cos x divided by sin square x. So I can write this as minus cos x divided by sin square x, which you can split it further, sin x 1 by sin x. Okay. So the sin square x, we have written like this, sin x into sin x. Previous page, if you observe, cos square is there, cos x into cos x. So cos x by sin x is called cot x. 1 by sin x is called cosecant x. So therefore, d by dx of cosecant x is nothing but minus cot x cosecant x, or you can write cosecant x cot x. So this is the second one. Now third one, differentiate cot x. This is very important. Cot x with respect to x. This also we do in the same method. Let y is equal to cot x. Then cot x means we can write as cos x by sin x. Then dy by dx is equal to sin x into differentiation of cos x Okay, I'll just rewrite this. This is not anything, this is simply a small dot. Sin x into d by dx of cos x minus cos x into d by dx of sin x, whole thing divided by sin square x. So sin x into d by dx of cos x is called as minus sin x minus cos x into d by dx of sin x is called as cos x, whole thing divided by sin square x is equal to minus sin square x minus cos square x divided by sin square x. Take out minus common. You are left with sin square x plus cos square x divided by sin square x. Remember trigonometric identity, sin square x plus cos square x is called as 1. So from trigonometry, sin square x plus cos square x is equal to 1. So that we substitute here. Minus 1 by sin square x. What we are left with now? Minus 1 by sin square x. We are left with, which is nothing but minus cosecant square x. So therefore, d by dx of cot x is nothing but minus cosecant square x. Okay. So these are all very important sums. Please remember. And next one important thing is that just before concluding the last video, I have done one chain rule type of sums. So I wanted to just clarify here an important point. Let us say we are having y is equal to cos x and y is equal to cos x square and y is equal to cos square x square, cos square x. Let us do first these three sums. Differentiate these three and understand the difference. In this case, first case, dy by dx is equal to d by dx of cos x, which is nothing but minus sin x. In this case, dy by dx is equal to d by dx of cos x square into d by dx of x square. This is chain rule where we applied now. First, we have to do the differentiation for cos x square. Then we have to do for the x square. That will become now d by dx of cos x square is nothing but minus sin x square. Then d by dx of x square is nothing but 2x. So the value of this is now minus 2x sin x square. In this case, y is equal to cos square x. This you have to write as cos x whole square. There is a difference between cos x square and cos square x. Whenever you find 2 for the trigonometric operator cos square, then we have to write it as cos x whole square. So that time dy by dx when you want to do, you have to use the power rule 2 into cos x whole to the power of 2 minus 1 into d by dx of cos x. So again for the function also we have to do. So this becomes 2 cos x, first one, into minus sin x. So therefore minus 2 sin x cos x. Okay. So please note down the difference here. Y is equal to cos x square and cos square x. So we'll conclude this video with the last sum here I would like to do here. For example, I am having sin square root x. I want to find out differentiation of this sin square root x. So first this 2 should go top one. As a power it should go d by dx of sin root x whole square. Then what we have to do when you are doing the differentiation, 2 into sin root x whole to the power of 2 minus 1 d by dx of sin root x into d by dx of root x. So please do remember this clearly. First sin root x whole square, we have to write 2 into sin root x whole to the power of 2 minus 1. That is the power. Next you have to do for the sin root x differentiation. Then you have to do for the root x. So all these things, how will they come out? First, this one. This will become 2 sin root x whole to the power of 1. Okay. Then d by dx of sin root x becomes cos root x. D by dx of root x becomes 1 by 2 root x. So this is the final answer. When you are having a function of this kind, carefully observe how we have done in the top, this third one. Same method we have to follow. So here root x is there. For root x, we have to do separately 1 by root x, 2 root x. Sin root x will become cos root x. Sin square will become sin root x whole to the power of 1. So please carefully observe and then apply the power rule and then chain rule. And for each function, you have to do correctly. Okay, friends, I'm going to conclude here for this. I will continue some more sums of this type of critical ones in the next video class. Thank you. And we are also supposed to learn explicit, implicit functions are there, and then inverse trigonometric functions are there. So we have got a lot of portion to cover. Slowly, we have to learn and then do them. Okay. Thank you. But keep revising the fundamentals without stopping.